Hello students, welcome to my channel, Engineer Ash Ma'am. In this video, we'll see numerical based on bolted connection. Bolted connection. Beam to column connection. Beam to column connection. So here is question. Beam ISLB 500 at 750 Newton per meter carries total factor UDL of 300 kilonewton. It is supported on columns ISHB 300 at 630 Newton per meter at each end. The connection is made using M20 bolts of grade 4.6 and steel FE410 design connection. What is given? One column is given. Size of column is ISHB, Indian Standard Heavyweight Beam 300, that is depth of a heavyweight beam or column is 300 mm and weight is 630 Newton per meter. Okay, next. Beam ISLB 500 is given. So beam here is ISLB 500. Beam size is ISLB, Indian Standard Lightweight Beam 500 at the rate 750 Newton per meter is given. This one is beam. And here is column. The connection is made using M20 bolts. M20 bolt is mean diameter, nominal diameter of bolt is 20 mm and grade is 4.6. Grade 4.6. This means ultimate strength of bolt equal to 4 into 100 equal to 400 MPa. And 41 steel grade is 410, that is ultimate strength of plate equal to 410 MPa is given. Okay, so there are total two types of sections are given in this question, ISLB 500 and ISHB 300. First, let's write down properties of sections. Properties of sections. First section is ISLB 500. ISLB 500 at the rate 750 Newton per meter. And second one is ISHB 300 at the rate 630 Newton per meter. Here is, I have already marked the values of ISLB 500. So you can see here in steel table for ISLB, for ISLB 500. For ISLB 500, what happened? For ISLB 500, this row you have to consider. BF is width of flange. Width of flange is 180. Thickness of flange is 14.1 and thickness of wave is 9.2. BF, TF, TW. BF, TF, TW. BF stand for width of flange, TF is thickness of flange, TW is thickness of wave. Values are 180 mm, 14.1 mm and 9.2 mm. Okay, next let's see ISHB 300. ISHB 300. Here is ISLB series, that is Indian Standard Lightweight Beam, then Wide Beam, Then heavy beam. Here is heavy beams. ISHB 300. Where is ISHB 300? Here. There are total 2 ISHB 300. Weight is 630 Newton is given per meter. ISHB 630. It means this one is second, 630. Okay. Value of, let's highlight this ISHB 300 row. Okay. ISHB 300 row. Width of flange, thickness of flange and thickness of wave. So here is this column in thickness of flange, thickness of wave, thickness of flange and thickness of wave. So here is value. There are values. First is width of flange. Width of flange is for ISHB 300, 215. Thickness of flange is 10.6 and thickness of wave is 9.4. Okay. 250, 10.6, 9.4. These are properties of sections. With the help of steel table, we can calculate or we can check properties of sections for different sections. Okay. Next is try angle 100 into 100 into 8 mm, one on each side of beam. Each side of beam. You know that it is column. If it is column, if it is beam, then with the help of frame angle, you can connect this beam to column. Okay. So assume size of this frame angle equal to 100 into 100 into 8. Next to find strength of bolt. Strength of bolt. So again, strength of bolt is depend upon two criteria. One is shear strength and second is bearing strength. Bearing strength. IS code IS 800 page number 75. Shearing and bearing. So let's first find shearing strength of bolt. First is end of slides. Let me add more slides. First is angle connecting beam web. First is angle connecting beam web. So you can see here, if it is column, okay. And if it is beam, If it is beam of cross section, drawing is not perfect. Just consider this is the I section. Okay. An angle is somewhere here. One is connected to this, and second one is connected to here angle, plate angle. One angle is connected to a of wave of beam, and second angle is connected to this flange of column. Flange of column. Okay. One plate is connected to wave of beam, and second one is flange of column. First we will first consider angle connected to beam wave. It means this angle is connected to this beam wave. If it is beam, then consider this angle is connected to this beam wave. Okay. So one plate will be here at this side, or other will be at other side. Okay. And one is here. I. One plate is at that. One plate is on this side. Second one on other side there. Okay. And this one is wave of beam. It means double shear will occur. One is plate, thickness of plate will be here, then thickness of wave, and then again thickness of angle. Okay. Thickness of angle. Here is thickness of angle, and here this one is this wave of beam. Wave of beam. It means double shear will occur here. If it is bolted connection, then double shear will occur. At this section, first shear will occur, number of curves, and here is second. It means bolt can fall into like this. Okay, in three parts. It means at this one failure, shear failure here, and second shear failure. Therefore, Nn equal to 2. It is called as double shear. Double shear. First, strength of bolt in double shear. Strength of bolt in double shear, which is equal to, with the help of IS code, IS 800, page number 75, page number 75, clause 10.3.3, here. Okay. I'm taking different color, red color. Shear capacity of bolt. VDSB equal to VNSB upon gamma MB, where VDSB equal to VNSB upon gamma MB, where VNSB equal to FU upon root 3 NN NB plus NS ASB. Okay. Strength of bolt in double shear. Formula is FU root 3 NS ASB. FU upon root 3 NN NB plus NS ASB, where ASB is area of shank and ANB is area of bolt. If it is bolt, and if it is threaded part of bolt, then it's called as shank, head, and this one is threaded part or net area. Okay. If failure occur at this here at threaded area, then you have to consider NN or NB. Okay. We generally consider AN or ANB because this threaded part is more weaker because area is less here compared to the shank area. If you're considering cross section at this shank area, then cross section will be perfect circular. And at here at threaded part, cross section will be reduced due to threaded part or net area you have to consider here. Therefore, neglect these terms, consider 0. Because we consider weakest section, and weakest section is at threaded part. Fu, ultimate strength of bolt is, we know that ultimate strength of bolt is 400 upon root 3 VDSB. Okay. If you are considering VDSB, the VDSB equal to VNSB upon gamma MB. So divide it by gamma MB. Gamma MB's value is 1.25 and a number of cuts are 2. Okay, number of cuts are 2. Number of cuts, one here or second one is here. So number of cuts NN equal to 2. It is called as double shear. NN is 2 and net area is 0.78 times pi by 4 d squared. And diameter is, but M20 is given, that means diameter is 20 square. Therefore, VDSP equal to 90.55 kilonewton. VDSP. Next is strength of bolt in bearing. Strength of bolt in bearing. Again, page number 75, IS 800. Strength of bolt in bearing denoted by symbol VDPP equal to VDNB upon gamma MB, where VDNB is 2.5 kb DTFU plate upon gamma MB. You can see here in I here. VDPB is VNPB upon gamma MB. Okay. Or VNPB is 2.5 kb DTFU and gamma MB is 1.25. kb is smaller of these four values. So we can calculate. 2.5 kb. kb we can calculate with the help of four formulas. Let's find first kb. kb. kb is smaller of 4. First one is E upon TD0. Second one is P upon TD0 minus 0.25. Or third one is FUB upon FUP. And last one is 1. So with the help of this, you can calculate KB, where E can calculate with the help of E. It should be greater than 1.5 times diameter of hole. And P should be greater than 2.5 times of diameter or nominal diameter. So with the help of these formulas, you can calculate KB. I have already uploaded video on this. But in these questions, I am considering a KB equal to 1 directly. Okay, KB equal to 1. Or you can calculate KB with the help of this. If E is 40, if 40 or P is 60, then you can calculate easily. Okay. But in this question, I am considering KB equal to 1. Because Cheyenne Curve, I am referring Cheyenne Curve's textbook, and according to their answer, they have considered KB equal to 1. Or you can calculate is just normal things. E equal to what? 40 or D, what is diameter of hole? Diameter of hole is depends upon clearance. If the diameter is 20, then clearance will be 22. Okay. Or E is 33 to 40 and P will be 60 to 65 in the range of. Okay. So answer will be in the range of 0.8 to 1. So we can consider 1 also. I'm considering the just following Cheyenne Curve textbook for this one. Next is strength of bolt in bearing. Strength of bolt in bearing, that is VDPB. Formula is 2.5 kbdtfu plate upon gamma MB. Okay. It is 2.5 into kb is 1, diameter is 20. Next is E. Thickness. Thickness is, which thickness? It's here. Minimum thickness you have to consider. thickness of wave of beam. Okay, thickness of wave of beam. It means this thickness. Thickness of wave of beam. Right. 9.2. Or you can see here. Thickness of wave of this beam. We know that this is beam ISLB 500, ISLB 500, and thickness of wave of this beam is TW. TW. Okay, thickness of wave. It is equal to 9.2. One angle is at this side, second angle is other side. We know that, and we have already considered thickness of this plate is angle is 8 mm. Okay, it means this is 8 mm and here is 8 mm. And wave of beam, thickness of wave of beam is 9.2 mm. It means total thickness of these plates are 8 plus 8, 16. 8 plus 8, 16. And second one is thickness of this wave of beam is 9.2. Therefore, minimum is 9.2. Okay, therefore T equal to 9.2. 2.5 into 1 into diameter is 20 into minimum thickness is 9.2. Thickness of wave of beam. Ultimate strength of plate is 410. On gamma MB is 1.25. It is equal to 147 kilonewton. You can multiply by 10 raised to minus 3, then you will get answer in kilonewton. Otherwise, 147 into 10 raised to 3 Newton. Okay, VD, PV. List value. List value, VDSB is 19.55, 90.55 and VDPB is 147. Therefore, list value or bolt value is minimum, which is equal to 90.55 kilonewton. Minimum of VDPB and VDS. Okay, 90.5. Then required number of volts. Next step is required number of volts. Required number of volts. Required number of volts equal to reaction at each end on volt value. Volt value. Reaction is 150. Total reaction, if it is beam and if it is column here, then total UDL is 300. Then half will be distributed to this column number 1 or half will be at this side. So reaction will be R equal to 300 upon 2 equal to 150 at this side and 150 here. Therefore, reaction will be 300 upon 2, that is 150. 150 kilonewton. And bolt value, we know that bolt value or strength of bolt is 90.55. Okay, it means 2. Number of bolts required are 2. It means strength of bolt is 90.55 and our enemy is 150. External load coming is 150 on that connection, 150. Therefore, total 2 bolts are required to carry this 150 kilonewton load. Okay. 2 bolts are required to carry 150 kilonewton load. Therefore, required number of bolts are 2. Therefore, provide 2 bolts at 50 mm pitch, 2.5 into diameter, 50 or 60 mm with edge distance of 40 mm. Okay. Pitch is nothing but 2.5 times diameter and h is equal to 1.5 times diameter of hole. And diameter is 20 mm and diameter of hole is 20 plus 2 is 22 mm. So you can calculate. And minimum length of angle required. Therefore, minimum length of angle required equal to 2 into 40 plus 50 equal to 130 mm. Okay. If it is angle, if it is connections, okay, number of bolts required are 2, which is bolt number 1, bolt number 2. Then each distance is center to center distance between two bolts. Each distance is 50 and this is distance equal to 40 and here is 40. Okay. Therefore, minimum length required is 40. 50 plus 2 times 40 is equal to 130 mm. Okay. Next is this side is done. Okay, this side is done. That is this plate or this angle plate connected to beam. Here is beam. Somewhere here is beam. Okay, beam. Next, let's design this side plate, angle plate, this side plate, plate number 2, which is connected to column. Okay, which is connected to column. Now, let's design this. That is this plate, angle connecting this angle connected to connecting this column flange. Here is column flange. Like this. Here is column. And this angle is connected to this column flange. Already calculated angle, this angle connected to beam. Okay, now we'll calculate angle connected to this column. Column will be up to here, I section, total I section will be there. Here, if it is I section column, then if it is beam, cross section, then here plate is connected to like this. Okay, or second plate is here. D. End of slides. Let me add more slides. Here. Second is angle connecting column flange. Angle connecting column flange. Connecting bolts will be in single shear because only flange will be here. Flange of column. Okay, flange of column will be here and just one plate is there. Okay, so it means only single. If it is bolted connection, then only single shear failure can occur here. Therefore, connecting bolts will be in single shear. Okay. As you already calculated value for double shear was 90.55 kilonewton. Therefore, the value for single shear will be half of double shear. Half of double shear. Or you can calculate with the help of formula also. I am writing here directly. That is 90.55 upon 2 will be equal to 45.3 kilonewton. Or you can calculate with the help of formula. Page number 75, clause number 10.3.3. Okay. Next is strength of bolt in bearing. Strength of bolt in bearing. We know that formula is 2.5 kb dtfu plate upon gamma mb. Okay, where kb equal to 1, just assume. Diameter is 20 mm. Thickness. Next is thickness. Thickness should be minimum out of thickness should be minimum. There are total two plates. One plate is thickness of flange. Okay, thickness of flange of column. And angle is connected to thickness of flange of column. Here is angle plate. Angle plate. Here. So minimum of T will be minimum of thickness of angle plate and thickness of flange. Okay. Minimum of thickness of angle plate. We know that thickness of angle plate is 8 mm and thickness of flange. Thickness of flange, what's thickness of flange? Of column. Here. Here is column, and thickness of flange of column, it means this one is 10.6. 10.6. 10.6. Not 10.6. Here. 10.6 here. 10.6. Therefore, minimum value is 8. Therefore, adopt equal to 8 mm. Now, substitute all values. VD, PB equal to 2.5 kb into D into T into FUP. Ultimate strength of plate is 410 into in kilonewton 10 raised to minus 3. 1 gamma m is 1.25. Okay. Then VDPB equal to 131 kilonewton. VDPB. Therefore, strength of bolt VD minimum of VDSP and VDPB. Okay, where VDPB is VDSP equal to 45.3 kilonewton and VDPB is 131 kilonewton. Therefore, bolt value or strength of bolt is equal to 45.3 kilonewton. Minimum out of these two. Okay, minimum. And required number of bolts, again number of bolts formula is same, that is reaction upon bolt value or VD or bolt value. You can write as bolt value. Now that reaction is 150, 300 upon 2 or bolt value is 45.3. Therefore number of bolts 4 numbers. Provide 2 bolts on each side of flange. Okay. Next is check the thickness of angle. Because in start we have assumed that angle section is 100 into 100 into 8 mm. This is assumption. This was assumptions. Let's check. Check the thickness of angle. Thickness of angle. With the help of clause 8.4. Back to the IS code. IS 800 Where is I said 100 here? Page number 59. Page number 59 of IS code, not page number 59 of PDF. Page number, where is 59? Here, this is page number 59. So you can see here page number 59. Page number 59, clause 8.4 here. Shear clause. The factor design shear force V in beam due to external action shall satisfy V should be less than equal to VD, where VD is design shear strength, which is equal to Vn upon gamma m0, where gamma m0 is partial safety factor. Partial safety factor against shear failure, which is equal to 1.1. We will see in 5.4.1 in a few minutes. Here, VP is AV FIW upon root 3, where AV is shear area. Okay, FIW is yield strength of wave. Back to the question. According to clause 8.4, factor shear resistance, factor shear resistance equal to shear area into FIW on root 3 into gamma m0. Okay, equal to ultimate strength FIW is 250 root 3 to gamma m0 is 1.1 and AV shear area equal to 2 into 100 into 8. Okay. You know that plate angle is like this. Therefore, thickness is 8 mm and this side is 100 mm at this side. And again here is 100 mm. Therefore, area is 2 into 100 into 8. FYW is 250 root 3 equal to 209.9 kilonewton, which is greater than 150 kilonewton. Therefore, set. Okay, it means factor shear resistance, factor shear resistance, factor shear resistance is 209.9 kilonewton. Okay, which is greater than 150 kilonewton. It means our friend is friend or our strength is greater than our enemy. Okay. Therefore, safe. Next, clause number 5.4. What is? Where is clause? Here, 5.4.1. On page number 29, 30 something. Remember the page 5.4. Strength here. Yeah. Table number 5. Page number 30. Table number 5. Partial safety factor for materials gamma m. Okay, gamma stand for partial safety and for material. So resistance covered by yielding or buckling, gamma M0, the value is 1.1. Okay, and for ultimate stresses, value is 1.25. Therefore, gamma M0 equal to 1.1 from page number 30. Right. A summary of this numerical summary. First step, angle connecting beam wave. Angle connecting beam wave. Okay. Just find shearing and bearing strength. Okay. Shearing and bearing strength, and the minimum of shearing and bearing will be your bolt value, and the number of bolts will be reaction upon bolt value. Okay. Then second step, here double shear will occur. Important terms is shear will be double shear. And second step, angle connecting column flange. Single shear will be here. Single shear and bearing VDPB. Okay, single shear and VDPB. Minimum will be bolt value. Again, number will be reaction upon bolt value. Important terms are here thickness, and thickness. And third step, check the thickness of angle. Okay. Thickness of angle with the help of clause 8.4. Page number 59, page number 30 are required here. Thank you.